Hi, today we are going to learn the second application of differentiation, which is maximum and minimum point. Okay, so the point at the curve y equals to fx when dy dx equals to 0, name turning point or stationary point. Okay, turning point could be maximum point or minimum point. Okay, at that point the tangent is parallel with x axis. Okay, when maximum point, d squared y dx squared is less than 0. When minimum point, d squared y dx squared more than 0. Okay, so actually in quadratic function, okay, quadratic function. Okay, so we have y equals to ax squared plus bx plus c. This one is general form. Okay, so then we use completing the square. Okay, completing the square method to convert into y equals to ax minus p squared plus q. This one is vertex form. Okay, from vertex form, we can identify the axis of symmetry and maximum or minimum value. So therefore, we can identify maximum or minimum value or maximum or minimum point from the vertex form. Okay, so this one is for quadratic function. So actually we have many types of function. Cubic function, power of 3, power of 4, power of 5, reciprocal. So then we need differentiation to identify the maximum or minimum point for that kind of function. Okay, so to explain that one, okay, so here let's say we have parabola with minimum value. Okay, so let's say we have point here. Okay, and we have tangent. Okay, so for this tangent gradient, okay, gradient is m. M is positive. Positive. Okay. Previously, we have learned m is gradient. Gradient is dy dx. So, dy dx positive. Positive. Okay. So, same thing if we have the left side. Okay, so let's say right here. Okay, sorry. Okay, sorry. We draw again. Okay, so point. This one gradient is negative. Okay, gradient is dy dx. So dy dx is negative. Okay. So now let's say at minimum point. Okay, at minimum point. Okay, here. Okay, so gradient is 0. Okay, so meaning that dy dx equals to 0. Okay, so in this situation, minimum point. Minimum point. Okay, so now let's say we have another curve here, parabola with maximum point. Okay, so then for this gradient, okay, so m is positive, dy dx is positive. Okay, so the right side, let's say right here. Okay, so this point, at this point, so gradient is negative, dy dx is negative. Okay, so at maximum point, okay, at maximum point, we draw straight line tangent to the maximum point. Okay, so like this. Okay, so m gradient is 0, meaning that dy dx equals to 0. Okay, because parallel to x exists. Okay, in this situation, maximum point. Okay, so from this explanation, we can conclude that for maximum point or minimum point, dy dx equals to 0, meaning that the gradient equals to 0. Okay, let's do example 1. Okay, find the turning point. Okay, just now, from the explanation before, turning point dy dx equals to 0. For the curve y equals to 12x minus 3x squared. So you find the first derivative, we differentiate 1, 12 minus 6x equals to 0. So then x equals to 2. Okay, so you have to identify the point. Point, we need the value of x and y. So to find y, you substitute x equals to 2 into y. So 12 times 2 minus 3 times 2 squared is 24 minus 2 is 12. Okay, so here we have coordinate 2, 12. Okay, so now you have to identify the coordinate is maximum or minimum. Then we find the second derivative. Okay, d squared y dx squared equals to, okay, this one negative 6. Negative 6 is less than 0, so set maximum. So therefore 212 is maximum point. Okay. Number 2, find the turning point. So turning point dy dx equals to 0 for y equals to 5x squared minus 5x plus 1. So dy dx is 10x minus 5 equals to 0. So x equals to 1 over 2. Okay, find the value of y. Then you substitute x half into equation 5, 1 over 2 squared plus 5 times 1 over 2 plus 1. Okay, so the answer is negative 1 over 4. Okay, so then the coordinate is 1 over 2, negative 1 over 4. Okay, to identify this one is maximum or minimum, you find the second derivative. Okay, so d squared y dx squared is 10. Okay, 10 is more than 0, so small, so minimum. Therefore, 1 over 2, negative 1 over 4 is minimum point. Okay, number 3, find the turning point, dy dx 0. So for y equals to x cubed over 3 minus x squared over 2 minus 6x. Okay, so dy dx is 3 over 3x squared minus 2 over 2x minus 6 equals to 0. So here we have x, we simplify. Okay, x squared minus x minus 6 equals to 0. This is quadratic equation. So to solve, you factorize. This one can factorize. So x minus 3 plus 2. So x is negative 2, x is 3. Okay, so now we have two values of x. So you have to substitute these two values into y. Okay, so when x equals to negative 2, y, this one, okay, negative 2 cube over 3 minus negative 2 squared over 2 minus 6 times negative 2. Okay, so this one is 22 over 3. Okay, so therefore we have first coordinate is negative 2, 22 over 3. Okay, so now we have another x. X is 3. So into y, y is 3 cube over 3 minus 3 squared over 2 minus 6 times 3. sorry, 6 times 3. Okay, so this one equals to negative 27 over 2. Okay, so therefore we have the second coordinate is 3, negative 27 over 2. Okay, so then we have to identify which one, these two coordinates, which one is maximum and which one is minimum. Okay, so from previous one, so this is your dy dx. Okay, x squared minus x minus 6. So dy dx is x squared minus x minus 6. Okay, to identify maximum or minimum, find the second derivative. D squared y dx squared equals to 2x minus 1. Okay, so substitute. We have two values of x. Okay, we have two values of x. So we substitute both values into d squared y dx squared. So when x equals to negative 2, d squared y dx squared equals to 2 times negative 2 minus 1, which is negative 5 is less than 0, so set. So maximum. Okay, so therefore negative 2, just negative 2, 22 over 3. So negative 2, 22 over 3 is maximum point. Okay, for another value, x equals to 3, d squared y dx squared is 2 times 3 minus 1, which is 5 is more than 0. More than 0, small, then minimum. Okay, so the point just now, negative 3, negative 27 over 2. So 3, negative 27 over 2 is minimum point.